This is section 6.6, function operations. This is part 2. We're going to learn how to multiply and divide functions today. Okay, and you'll notice, again, on the front of your sheet, everything on the top is exactly the same as the previous one. The only thing that was a little bit different here was how we're going to multiply and divide. Okay, so a couple things here as we look through. To multiply functions, it's going to be similar to what we did with add and subtract. Okay, we're going to take the two functions, we're going to multiply them together. Sometimes they're going to be monomials, you just multiply them. Sometimes they're going to be two binomials. It could be a monomial times a binomial where you have to distribute, or it could be two binomials where you have to use the FOIL method. Or it could be a binomial times a trinomial where you have to take and use the distributive property. Okay, and then you're going to have to be able to find domain. Now, you're also going to have to be able to divide functions, okay, where you're going to put each function into a fraction and simplify. Now, on the division ones, you're going to have to look to factor and see if there's things that you can cancel out, okay? Now, again, we have this down here, the domain part. The domain part is exactly the same as it is with addition and subtraction. The two things you're looking for is there a square root? If there is, you take what's inside the square root, make it greater than or equal to 0, and solve. If there's a number on the bottom of a fraction where you have a variable on the bottom of a fraction, you have to take whatever the denominator is, set it not equal to 0, and then solve that as well. Okay? Okay, so let's take a look now at some examples. Okay, so we have some examples here in front of us, and it says here, let f of x be x squared minus 9, g of x be x plus 3. We want to find f times g and f divided by g. So, as we look at this here, we take f of x times g of x. So f of x is x squared minus 9, and g of x is x plus 3. Now, in this case, we have two binomials, so we're going to have to use the FOIL method. So first times first is x cubed. The outsides is positive 3x squared. The inside is negative 9x. And last is negative 27. Okay, now, you'll notice as we've done this, there are no like terms here, so I'm finished. That's all I have to do in this case. The one thing I do have to finish up with is the domain. There's no square roots, there's no fractions, so my domain is going to be all real numbers. I can put whatever I want in for x. Okay, so f of x divided by g of x. Okay, so I'm going to take f of x, x squared minus 9, that's going to go on top. I'm going to divide that by g of x, which is x plus 3, that goes on the bottom. Okay, now, as we look at this, we've got to see, is there any one of these top or bottom that I can factor? Well, if you look at the top is a perfect square. It's the difference of two squares. So I can make this x plus 3, x minus 3. Okay? And as I look at that, again, I can divide that now by x plus 3. Okay, before I go any further and do any canceling, I'm going to go through my domain. We have something in the bottom of a fraction, so I take whatever's in the bottom of the fraction, set it not equal to 0, because the bottom cannot be 0. And now I solve that equation. So I'm just going to subtract 3, and x cannot be negative 3. That's my domain. If I have negative 3 as x, that's going to make 0 in my denominator, so I can't have that. Okay, so now let's go back up to the top. Things that are the same, x plus 3 and x plus 3 are the same, so I can cancel those guys out, and I'm left with an x minus 3. So if I take f and divide it by g, I end up with x minus 3. Okay? So there are going to be some cases where you're going to have to simplify it, especially with division. Okay, let's take a look at example number 2 now. We've got f of x is 3x plus 2, g of x is 2x squared. What are f of x times g of x and f of x divided, or g of x divided by f of x? So, f of x times g of x. F of x is 3x plus 2 times g of x, which is 2x squared. Now in this case, I've got a monomial times a binomial. I'm going to distribute here and here. So when I do that, I've got 6x cubed. Okay, now, there's nothing else here I can simplify, so now I just need to figure out my domain. And again, on my domain, there's no square roots, there's no fractions, so my domain is going to be all real numbers. Okay? Now, I want to take g of x divided by f of x. So g of x is 2x squared. I'm going to divide that by f of x, which is 3x plus 2. Now, as you look at this, I can't factor the top, and I can't factor the bottom. So essentially, I'm done here. There's no simplifying to take care of. But I do need to do my domain. Again, we have a fraction, so I have to set the bottom of the fraction not equal to 0. If I subtract 2 and I divide by 3, in this case, x cannot be negative 2/3. Negative 2/3 will make the denominator 0. Okay, so there's going to be some problems where you have division where you have to simplify, and some where you don't have to simplify. Okay, let's take a look here at problem number 3. Again, I'm finding f of x times g of x. So f of x is 3x squared minus 11x minus 4 times g of x, which is 3x plus 1. Now, this is the case of a binomial times a trinomial. 2 terms times 3 terms, so I have to use the distributive property. And what I'm going to do is I'm going to break apart this binomial. I'm going to take 3x times everything in the trinomial. And then I'm going to take the other part, which is 1, and take that times everything in the trinomial. So now I'm going to distribute, and I end up with 9x cubed minus 33x squared minus 12x. Distribute the 1 plus 3x squared minus 11x and minus 4. And now I have to combine my like terms. Okay? So when I combine them, I don't have any 9x cubed, I don't have any other cubes. Negative 33 and positive 3 is negative 30x squareds. Negative 12 and negative 11 is negative 23x's. And I don't have any constants left, so it's just negative 4. Okay, so now I've combined all my like terms, and now I need to do my domain. There's nothing else I can do to that problem. Again, are there any square roots or division? There is not, so my domain is all real numbers. Your domain is not always going to be all real numbers with multiplication. You have to be careful with that. Don't just assume that. Okay? All right, division. F of x divided by g of x. So f of x is going to go on top. 3x squared minus 11x and minus 4 over g of x, which is 3x plus 1. I cannot factor the bottom, but I can try and factor the top. So when I factor the top, I need factors of negative 12 that add to negative 11. So the top is going to become 3x squared minus 12x plus 1x and minus 4. This is going to jog the memory a little bit. Okay? So when I factored that out, I found factors of a times c that add to the middle term, replace it. Okay? Got to jog the memory on factoring a little bit here. When I put parentheses around the first two and the last two and factor this out, my end on the top, I'm going to end up with 3x plus 1 on the top times and x minus 4 all over a 3x plus 1. So once you factor this by grouping, you end up with 3x plus 1 and x minus 4. Now, before I go any further, I want to do my domain. Again, 3x, the bottom of the fraction, cannot be 0. So when I solve this guy out, I get 3x, if I subtract 1, cannot be negative 1, and x cannot be negative 1/3. That's my domain. Once I have my domain finished up, cross out the like terms, and my final actual answer is x minus 4 if I divide those two functions. Okay, so this kind of gives you a good idea of some examples here of multiplying and dividing functions with some different domains and things like that. Okay, don't forget to complete your WSQ. Again, this is section 6.6. This is part 2 of multiplying and dividing functions.